Hi, my name's DaiWai, and I'm going to talk to you about nursing role in the Curing Coma campaign. These are my disclosures, none that I think are pertinent to today's talk. I do want to mention that I am the co-chair of the Curing Coma campaign along with Claude Hemphill. Let's start with some simple definitions. Care versus cure. So these get mixed up a lot. There's care, and when we talk about care, that includes caring about. So when we care about a person, that's an emotional response. On some level, I think all of us have someone that we care about. All humans care about patients and people, but that's not what I'm talking about today. What I'm talking about is caring for a person. So caring for is the actions or the interventions that we perform on a day-to-day basis on how we care for the needs of the patient. That's kind of a nursing role, and that's my role. This is differentiated from the physician role, which instead of caring is curing, and it's curing from. It's removing the disease or resolving the condition from which the patient is suffering. That doesn't mean that physicians don't care, and it doesn't mean that nurses don't help cure, but our prime role as nurses is curing, and the prime role for physicians is caring. This model extends. If you look, the physician model is one where you have one physician who is in charge of caring for, right? Curing many, many patients. Whereas the nursing role is a smaller number. It's more intimate. Nurses don't have the same number of patients in a given day that physicians do. And this has been important as it helps differentiate nursing and physician care. Now, notice I said and. It's not really it's not that nurses are better than physicians, right? Nurses aren't better than doctors. We're not worse than doctors. We have a different role. So I really want to change the conversation from comparing us against each other to comparing our roles and understanding how they overlap and how we work together. Think about a day in the life of the patient with coma. Somewhere around 8 o'clock, 7 o'clock in the morning, the doctor and all the other, all of his professionals and multidisciplinary team comes by, and the physician will come by and he'll prescribe new medicines and new interventions and sort of a plan of the day. That's important. What the physician does is important. But so is what the nurse does. So this little yellow bar is the 30, 45 minutes of physician care, and the remaining 23 hours and 30 minutes of the day is nursing care. So I'm not saying we should ignore what the physician does. I'm making a much simpler argument. And really, I'm making three arguments. One, we as the nurses are responsible for keeping this comatose patient alive. If the nurse can't help keep the patient alive, if we can't care for the patient, we cannot later cure the patient. If they're not alive, there's nothing to cure. Discovering, and I'm going to talk some statistics later, discovering how to care for the patient in a consistent manner will reduce the burden of science on how to cure the patient. In this manner, nurses are pivotal. We are integral to caring for patients and to solving the curing coma problem. So if we don't provide good care, we don't have the opportunity to cure. I think I've shown that. If we can't keep the patient alive, I don't think there's much of an argument for that. So I'm going to start by saying nursing is important because we as nurses are on the front line. We're there the 23 hours and 30 minutes when a physician is not there. taking care of the patient and keeping the patient alive, and that helps set up the field from which we can cure. If the patient is in a coma and they die, they can't be cured. Now let's talk about this second argument about sample size. I'm going to give you a rather simple breakdown of statistics, and I know people just love learning about statistics, right? So let's talk about sample size, and I'm going to have a pretend experiment where I have an intervention for stroke, and I have patients come in, and on average, their mean stroke score is 19. Pretty bad stroke. And my intervention brings that stroke score down to 10. So I have two means that I'm comparing, and I want to compare the difference in the two means. You'll see that in all three of these examples, the difference is 9 points. But in the first example, there's a very big effect size because the standard deviation is smaller. In the middle one, the effect size is medium because we have a bit of a standard deviation. And in the bottom one, we have a very small effect size. The difference is still 10, but it's not as big a 10 difference, right? We're not as confident of our point estimates. We are not as certain of the 10 and the 19 as we are in the big effect size. More simplistically put, if you have a small effect size, you need a big sample size. If you have a big effect size, you need a small sample size. Now, I'm going to get this a little bit more complex, and I know that right now when I show this regression formula, some of you are getting uncomfortable, but we're going to talk about regression, and you're going to be okay. You're going to be okay. So don't get scared. Hang with me. We're going to learn statistics the easy way. The standard regression formula is the one that I just showed you. And this can be read in sort of standard language. This formula, y equals beta naught plus beta 1 x1 plus beta 2 data, this just says the outcome is predicted by where we started plus the influence of a bunch of other variables plus an error, some degree of error. I'm going to color code this just to make it a little easier. The outcome, blue, the y, is predicted by, that's the equal sign, where we started, the beta naught symbol, plus all the plus signs, plus influence from a bunch of variables, all those gray, plus error. So we can see that there's a way to map this out into that term. I'm going to use a little bit more of a real example. 90-day modified Rankin score is predicted by how well the patient was before the stroke, plus what was their NIH score on admission, how old were they, did they get a thrombolytic, were they male or female, plus a whole bunch of other stuff that we didn't even bother to measure, plus error. Same color coding as before. The outcome is predicted by how well they were, plus a bunch of variables, plus error. In this case, discharge score was predicted by how well they were before the stroke, their age, their sex, their stroke score, a bunch of other stuff, and error. Now, what I haven't pointed out, or I haven't spent a lot of time talking about, is the other stuff. And that's where I want to go now, because in research, we often measure lots and lots of variables, and then we call it the other stuff. But the other stuff is nursing care. See, we never really measure nursing care. And I think that nursing care makes a real difference. It makes a difference, but can you measure nursing care? That's the hard part. Can you measure nursing care? I'm going to give you another regression formula in a slightly different format. So some event happens, like a patient has a stroke. And there's a bunch of variables. There's a bunch of things: age, sex, how bad was the stroke. And then there's an intervention we do. Maybe we gave them a thrombolytic. Maybe we took them to interventional radiology. And then there's these variables at the bottom: nursing care and other stuff, confounders. And each of those individually explain some proportion of variance in the outcome. In other words, that's that R squared. So in my made-up example, if I know 4 variables and an intervention, I can get an R squared of 0.7. I can explain 70% of whether or not a patient will do well after their stroke. But I haven't counted for nursing. If I know nursing, maybe I can explain all of the outcome. And this is my argument both today and tomorrow, that I'm talking about why is nursing important. That's because we make a difference, and we can help figure out whether or not a patient's going to get better or worse if we understand nursing. There's other things we don't measure, by the way. I said we don't measure nursing, but we also don't measure if the patient was born on a Saturday. We could measure that. We could measure, does the patient like coffee? We could measure whether or not the patient likes to watch movies. There's lots of things we don't measure. So why am I so adamant that I think we should measure nursing, given that we don't measure all of these other things? Well, because I'm trying to make the argument that nursing isn't just a confounding variable. Nursing does something that moves the patient forward or backward on their trajectory of care. We have to understand all of the things, all of the variables that impact whether the patient in a coma will have full recovery or no recovery or somewhere in between. And the only way we can understand how well they will do is if we understand everything in this little black box called the care interventions. We need to understand every type of intervention. And when I'm turning a patient or bathing a patient or cleaning a patient or walking a patient, those are interventions, and we need to understand them. So I'm saying that if we discover all of the caring for variables, it's going to give us a bigger effect size, more space between our two means. And that will mean we'll have fewer patients required to discover the cures. Now, remember, I said nursing care makes a difference. I also said we're not sure how to measure it. But we do have a theory on how nursing makes a difference. And that theory is called the Q response theory. This is an image of the Q response theory. And this is available at PubMed. If you want, you can reach out to me. I'm happy to share a copy of this article. I would also, especially for this audience, like to mention that this is a paper that I published with Stephanie Ortega Perez, who is from the Barranquilla, Colombia. She was at the University of Bogota, University del Norte School of Nursing, and together we published this theory paper. So you can also reach out to Dr. Ortega Perez. In brief, I'm not going to go over the whole theory, but in brief, some event happens that causes an injury to the brain. Subarachnoid hemorrhage, a baseball bat, a bullet, something causes brain injury. And that brain injury causes decreased function. Now, when the brain injured patient is in the hospital bed, they're giving off cues. They're wiggling around, or their heart rate's up, or they're not moving at all, or their neuro exam has changed. These are cues that we as nurses pick up on. We observe, we interpret the meaning of these cues. We also have a bunch of interventions we need to do. We need to monitor the ICP. We need to turn the patient. We need to bathe the patient. We need to give medications. We need to adjust the height of the bed. And if we do these interventions at the right time, based on the things we observe, then the patient moves forward towards recovery. If we do them at the wrong time, then they get worse. Or they're slowed down. They're stuck in that no recovery zone. I'm going to give two examples, two really easy examples. The first is an example of a bad outcome based on timing. I'm working in the hospital, and the doctor wants a daily weight. He thinks weight's important so he can track how much fluid. And I walk into the room, and the intracranial pressure was 7, and now it's 18. It's much higher. And I assess, well, it's not 20. So I'm going to do my stuff. And I lower the patient's head of bed, and I weigh them, and I bathe him, and I change the linens, and I clean their bottom. And the next time I look up, the ICP is 35, and the patient's right eye pupil is fixed and dilated. That means that my interventions, bathing the patient, were done at the wrong time, and they caused more harm than good. The patient did not do well. Now, I say this because if I, as a nurse, can do an intervention that causes harm, I must be able to do an intervention that also causes good. So let's look at an example of that. Same scenario, the patient wants a daily weight, or the physician wants a daily weight. I go into the room, the ICP was 7, now it's 18. And I say, you know what? It's not 20, but it's kind of climbing. So instead of lowering the head of the bed and giving a bath, I raise the head of the bed. I give the patient some pain medicine. I wait 30, 45 minutes, an hour. Then I get the patient's weight, and I give them their bath. This patient never sees an ICP of 35. They don't have worsened brain injury. In fact, they move to the right of this towards recovery because I did the right time of the intervention, the right thing at the right time. So these are simple examples of caring for. These are things that we do. Lots of things that might impact consciousness. When are we going to feed the patient? How much? What kind of food? High nitrogen? What about mobility? Should we turn the patient in bed? Should we do range of motion? What about sleep-wake cycle? Should I keep the patient awake and stimulated, always playing loud music in their room with the bright lights on? Or should I make it dark? And when should I make it dark? What about music? Should I play loud music or soft music? Rock and roll or jazz? Should I touch the patient? Should I keep them cold? Should I have a cover on them that makes them, bothers them? What about the family? Should I let the family come into the room and wash the patient's hair? What about when do we send a patient from the ICU to the next area? When do we send the patient for rehabilitation? How long and what kind of rehabilitation do we do? These are timing. These are really, really big nursing variables. And these are decisions that need to be made. So this is that bottom example that I have is in order for us to cure patients of coma, the fundamental step before we cure the coma is to care for the patient in coma. If we don't care for them, we'll never get a chance to cure them. And I thank you for listening, and I'm available. I'm going to listen for some moderated questions, I believe, and I'd love to hear from you. This is my email. Thank you very much.